Hey, hello and welcome back to the second part of the tutorial for lab 2 from class Papa. So let's open up your Hypermesh and you will be again greeted by the user profile. Choose OptiStruct and click OK. So for the 2D we will still follow the same method with few changes, but we will use the same concept. So first of all, create the material. Go to the material icon and create the steel material 1 and create edit. E for the Young modulus and U for the Poisson ratio, ratio for the density. Okay, click return, and then you're all set up for the material. So next should be hyperbeam and assign, but since we are not using hyperbeam and 2D, we will going to create our own let's say component. So first of all, go to the geometry at the bottom right of your screen, click geometry and make a node. So change your viewport to this 3-axis view so you can see easier. Change the XYZ to 0 for the origin. Then since the tutorial put 25 radius earlier in 1D, so it should be diameter 50 and in the Y direction 50. So change your Y direction to 50 and then create. So you can see you can't see anything yet. Click on the screen and press your keyboard for F. Okay, so now you should see something 2 dot. Okay, next we're going to make the end of the bar, which is in the X direction. Change the point to 500 per se, and then click create. And then we're going to make let's see, okay, at the end there. So we're going to make another point, the last point, which is in the X direction 500, but no change in the Y direction, so 0Y. Great. Okay, great. You can see the 4 point right now and press return. Okay, next we are going to make a line out of this 4 point. Go to geometry again, click lines and change to the next icon, linear nodes. Okay, click linear node. Okay, click the first point and the second point, create the second point to the third point, create the third to the fourth point, create the fourth to back to the first, create. Okay, well done. You make your first cross section of this rod or bow or whatever. So from this we are going to make a mesh out of it. So let's see first. Expand all, you have your component. We skip a few steps, but yeah, you have the component right now, the material, and supposedly you should make properties, but let's make the properties right now. So properties. Okay, now it's not a bar since you learn already. You're not a dummy anymore. And then we should put it let's say cross. Let's see, cross section. Cross section. Okay, change the type to 2D because this is a 2D, and the card image to P shell. Material, you already made it, so we we put it still. And okay, this property should be 2D and you cannot create. You don't click the create yet, click the create and edit, because you're going to put some thickness to it. So the thickness should be 50 by 50, should be 50. Alright, so everything is set. Press return and another return. Okay, now you should see some properties of the cross section here. Now it's time to make the meshing. Meshing, you go to 2D and spline. Actually, there are other way to create a mesh other than spline. You can auto mesh, you can, for the 3D you can tetra mesh, but we go that a bit later. But for now, just choose the 2D and click the spline. Okay, at the line section, just click all the line that you have made earlier and create. Okay, a mesh should pop up, and don't change anything, just stick to the default value and mesh. Okay, return. Now you should see something like this, but for a better view, you should go to this icon, change it to shaded element, so you can see what you do actually. Okay, return. So now you have the material, you have create the node and lines and the meshing, you made the properties, and you have the component, but you haven't assigned your properties to the component yet. So let's go back to the properties collector and go to this, see this create, update and assign. Click assign element, just click all, type 2D property. Okay, you want to assign the properties to this mesh, so the cross section meshing, the cross section property that you made earlier will go to this mesh, so just click assign. Okay, return. So if you want to confirm whether your meshing actually inherit the properties, click the component and see property unspecified. Okay, if it show unspecified, just click it, property and cross section. Alright, okay, so now it will inherit whatever you made earlier, the property and the material. Okay, so good job so far. Now let's see, the four first component is done, and the leave us with load collector, and the load collector is the same for every simulation that you're going to do. Just go to the load collector icon here. I made the first force red color, create, and next SPC, change the color to blue and create. Okay, so what is activated right now is the SPC. As you can see, set current load collector. Okay, you can see SPC right now. So we want to make, since the SPC is activated, we make the constraint first. Change the view into YX view, click constraint nodes, click the nodes by Windows and click first, click second, click third, click fourth and fifth or something like that. So make sure it is interior. You want to select the end of this portion and select entity. Okay, now you know, change the basic setting into 50, tick everything and create. Okay, you should see something like that. So change back to I think don't need. So press return, and now we are going to apply the force. So change the SPC here at the bottom right to force, and go to analysis, forces, click the node by window again, and then first click, second click, third click, fourth click, fifth click, and then in the interior and select entity. Okay, now uniform size, change it to 50 and change the view into 3D. Okay, now the force is going to be on the Z axis, so change the Y axis here into Z axis. So put the force whatever value you want, and then click create. Okay, return. So now you should have something that look like this. Okay, so we finished the 2, 4, 5. 5 step. Last but not least is to save your file first. Go to File, Save As, Model. Go back to your 2D file. File name into 2D. Hypermesh. To whatever you want to call it. Save. Okay. Apply the load step. Put your your experiment name into something. 2D experiments, linear static. Okay, SPC and load, tick both of them. If not, then the SPC, click the equal button to change it to SPC, and the load to the force. Okay, so done. Create, return. Okay, now you probably done, and now we are going to run the simulation through OptiStruct. Click OptiStruct and export all, run option analysis, memory option to default, and OptiStruct. Okay, congratulations, you just ended your second tutorial for the 2D because analysis completed and the job is completed. If you want to see the result, click the result again, and as I mentioned in the previous tutorial, click the contour to see the contour, and for this the result type that you want, result type is the displacement right now, and click apply. You should see some color changes. If you want to see the full deformation of this mesh, just play with the slider or just click the play button here. Okay, so you can see vibrate like crazy shit. So depending on your value, the deflection might be a little different than what I have, so but whatever. Okay, you have your value. Okay, so please stop the motion, screenshot if you want, take this result, put it in your report, and you go on with your life. Next, you can change it to the stress. Okay, the result type for stress, averaging method will be changed into simple, and click apply. Okay, you can see the color changes to the most stress point of the bar beam or whatever you want it. Okay, you can still simulate the result, screenshot whatever you want, and then you are finally done with your 2D experiment. Okay, let's move on to the 3D. For the 3D, just clear everything up. For me, if you want to a quick restart of your system, just press F2, delete model, and yes. Okay, this will clear everything from the menu, and you want to start fresh. Okay, for this tutorial you need to make I think you have to make a model first from SolidWorks, and then save it as IGES. So when you import, so you go to File, Import Geometry. Okay, I already have few of these. I want to clear. So click here to find where your IGES file is located. And for me, I think it is in my private study folder. CAE lab 2 3D. Not here. There I have 3D IGES. This is the 3D solid view, but this is the IGES file. Click open and then import. Automatically you will see something like this. Click you can change the port, or so now you wanted to see the whole solid. Click this icon and shaded geometry surface edge. Okay, so now you have a reference. This is not the actual model, but this is the reference that you are going to mesh. Okay, let's restart with the basic step, which is the material. Still isotropic, make one, create edit, E and U are show the usual thing, and press return. So once you return, you have your material ready right now. Okay, next is supposed to be your properties. Properties, if go to create, change the name of your properties into 3D properties. Change the color, whatever you like. Change the into 3D. Type 3D. Card image is P solid, and the material is the material that you already made. So create. You don't have to create edit because the solid will define itself. So create. So now you have a properties called 3D prop. So now time for the meshing. As I mentioned earlier, there are numerous ways you can create mesh with 2D auto mesh or 3D tetra mesh. But for this tutorial, we are going to show you how you're going to mesh using tetra mesh. Click tetra mesh, and in this option, choose volume tetra. Enclosed volume solid, yes. 2D type, you change it to R3S, and 3D type, change it to tetras. Okay, leave everything as default. The element size, the smaller the element, the longer it's going to take for it to mesh. So for this experiment, just use 10. 10 should be enough. So click the solid, click, it should be white, and then mesh. Wait a few seconds, it's mesh. Okay, and then you can see the mesh already finished, I mean. Okay, so press return. So for now, you go to your model panel and hide the 3D. You don't need the reference anymore. Okay, this is the 3D mesh that you have created. Okay, so oops. So now you have the material, you have the properties, you already create the 3D, and you haven't assigned it yet, but now we are going to assign it. Go back to your, I think the shortcut way would be just click the auto tree and property, click 3D prop. Okay, it should be easier this way than to update everything. So now you learn a few steps and shortcut on how you can apply certain thing to certain element in this model panel. So now everything is done. Time to create the SPC and the force. Okay, the SPC create from the load collector icon, and then force, change the color into red, create. Okay, now you have two load collector, which is SPC and force, but the activated one is the force, as you can see on your left, on your right bottom window. Force is activated, so you should do the force first. So go to analysis, force, z direction is the force going to act upon. So I think I want to add it a bit, 100. Okay, it should be 1 2 3 4 5. Okay, it should be good. Uniform size to 50, and I want to click the end of this node. Okay, there, the white one, and click create. Okay, should see something like this, the force. Okay, so return force, change it to SPC, and put a constraint next. The basic step is the same for everything, so it should be no problem for you to follow it, and you can try and error on different value that you think you need it, but otherwise just stick to the tutorial. So for this constraint, you want to constrain the whole face, so the node should change to face, and you click the end of this. Okay, relative size, change it to 50, tick everything, and then create. Okay, see something like that, and return. Now the last step of this, which is the load step. You have the material, you already create the 3D and assign the properties, and you have the component for it. The load step is already made, load collector already made, and last is the load step. Go to analysis, and under load step, change the name into 3D experiment. The SPC, change it for SPC, and the force, change it to the force for linear static type, and click create. And then you're done. Congratulations again, you just finished your lab 2. Okay, so now it's time to run the simulation. Click OptiStruct, use the same setting from the previous, and click OptiStruct. Okay, analysis complete, good job. Job complete, good job. And you can view your result here. Okay, click the control line again and press apply. Now you should see something that look like this. Screenshot, whatever you like, and then you can change it to stress also. Averaging methods, change it to simple, and click apply. Okay, you can preview. Okay, as you can see, wobbling like crazy. So pause, take the end of it, and then screenshot whatever you like, so you can finish your tutorial. Thank you for listening. This is your Mr. Nice Guy providing you tutorial on how to survive CAE in Papa class. Thank you and goodbye.